Okay guys, we're going to try this again. The video that I just made did not work. The sound was horrible. So round two, here we go. Alright, so we're going to do common exponential functions. We have 4 listed here. These are real life problem situational functions. The first one is an exponential growth, just any type of exponential growth. Anything that is just growing, multiplying over and over again. Is just a basic. You start with the initial amount and you do times it 1 plus the rate that it's growing raised to the time that you want it to grow. And you get this exponential growth graph here, and we talked about this the other day, but that's exponential growth. Now, then we have logistic growth. Logistic growth is what the virus does. This is what viruses do. There is what we call a carrying capacity constant. These are constants. That basically is a limiting. It cannot go beyond that number. Notice with exponential growth, there is no limit. But with the carrying capacity, it's going to stop. And it starts out exponential, and then it starts slowing down its growth and eventually leveling out and stops growing. This one uses our E. It's in the formula. We will look at some problems using logistic growth, but that's what the virus is doing. It's growing with a logistic model. And so currently we are waiting on this virus to take its turn and flatten out that curve so that it will no longer be such a difficult situation. The others are from financial math. Financial math is compound interest. It's very, very important to understand how compound interest works. Hopefully that you are in the mind frame of saving your money, and this is what we're going to be looking at, is what happens if you save your money and how it can grow. And so we have 2 formulas. One is based on how many times a year you compound, and the other one is based on a continuous compounding model that doesn't actually ever really work. It's more of a theoretical. And again, you see that you're using E in it as well. So let's look at an example. Here we have an example, and our letters in our formula represent here. They were on the previous slide, but I threw them in here as well. P stands for the principal, R is the interest rate, N is the number of time compounded per year, T is the number of years, and A, of course, is the final amount that we're trying to calculate. So if you'll look just quickly, find the accumulated value of an investment of $20,000. That is how much money we have. That is our P for this problem. We have $20,000. Now we're going to invest that for 5 years, so that's our time. T for our problem is going to be time. It's going to be 5. Our interest rate is 7%. Now 7% needs to be turned into its decimal form, which is 0.07. And then A, it says compounded semi-annually. Semi-annually, that means N is going to be 2. For part B, we have quarterly, which means N was going to be 4. And part C says compounded monthly, which means C is going to be, not C, N is going to be 12. We'll use the same numbers for these, and we will get similar answers. Part D says continuously, and that's where we'll use the other formula. We'll use the other formula. So I'm going to try to squeeze these all down here. The final amount is what we're solving for. So get you a good calculator, as we're going to need it. Stop the video and go find it. You can't do these without a good calculator. And the only way you know if you're doing them right is to match my numbers. So the first one, we're going to do 20,000 times 1 plus 0.07 over 2 raised to the 2 times 5 power. So what you're going to do is you're going to do the 2 times 5 power, because if you don't, you will not type it in the calculator correctly. You got to be real careful with that. And I'm going to go ahead and change that to 10. And so that is what I'm going to type into my calculator. Hopefully I've got one that does order of operations, and that's what I'm going to type in. And if I type it in correctly, you should get $28,211.98. Now, it specifically says round to the nearest cent, so make sure that yours matches mine. Check your calculator, stop the video, and see if you can't get it to work. All right, part B. We're going to change the n to the 4. We're going to do the exact same thing. 20,000, 1 plus 0.07 over 4 this time, to the 4 times 5 power, and that's going to give me raised to the 20th power. That's what I'm going to type in my calculator. And again, hopefully you get what I get. When I do it quarterly, I get $28,295.56. And that is compounded quarterly. All right. Try C by yourself. Stop the video and see if you can do C by itself. And then start it back up and see if you get what I get. 20,000 times 1.07 over 12 to the 12 times 5. And it would be to the 60th power this time. And again, I did my math right. If you did your math right, I get 28,352.51, and I hope that's correct. All right, now part D. Part D uses a completely different formula because it says continuous compounding. And so we're going to use a different formula. We're going to use a different button on our calculator. It's going to be 20,000 e to the 0.07 times 5. And so on your calculator, just hit the e to the x button. You should have an e to the x button. And it would be e to the 3, I don't know that one. Can't do that. 0.35, I think. And what you should get is $28,381.35 for part D. All right, this is tough, but it's just plugging numbers into a calculator, which you should and must be able to do.